Hey everybody, it's Mr. Mott. What we're going to do is go through how to graph your data from your density of liquids or density of solids lab. All right. Um, so what we're going to need is some graph paper, or if you're using Notability, it's a pretty slick feature that you can do. If you go up to the three dots in the upper right-hand corner, we can press that, press Templates, and then go to Grid and hit Done in the upper right. So all of a sudden you've got a nice piece of graph paper here. All right. So what we're going to do is going to graph our data. So what you want to do is make an XY coordinate, giving yourself some space here on the Y and the X so we can label everything. Okay. On the Y-axis is going to be mass, usually in grams. That's how we measured it. And then on the X-axis is going to be volume, and that's going to be in milliliters. All right. So what we're going to do now, we have to figure out how much each of these lines or boxes is worth, because we want to be able to graph our data. And graphs are visual, and so we want something that's big that we can see the trend more easily. All right. First, we want to make sure that our origin is at 0, 0. If something has 0 mass, it will take up 0 volume, and vice versa. Mass is the stuff that's in an object, and volume is the space that it takes up. So if there's no stuff, it can't take up any space. All right. Next, what you want to do is you want to look at your graph, and you want to count how many boxes you have on each axis. We can start out with the on the y-axis mass. So if I had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you have 10 boxes. Your graph paper may have more. If you used a template that had smaller boxes, you might have more. But we've got 10 on my screen. So you want to look at your highest mass, your largest mass for your object. For if you were doing the density of liquids, you'd be looking at just the mass of the liquid, not looking at the mass of the cylinder plus the liquid. All right. So let's say that our highest mass was 90 grams. If our highest mass was 90 grams and we have 10 boxes, we could make each box worth 10. And then we'd know all of our data would fit there. Okay. Last one would be 100. Now, when you choose your scale on your on the x-axis, it doesn't have to go up by tens. It can, but it doesn't have to. You just want to make sure that each of these spaces is worth the same amount. I've seen sometimes people will do this, and they'll sort of skip some numbers. I might go 10, and I might go to 50 here. But then each line won't be worth the same thing, so we don't want to do that. That squiggly line is no bueno. All right. So let's say that you had your highest. So let's count our squares again. Let's not forget to do that. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay. If your highest volume was 1, for instance, then, or excuse me, if your highest volume was, say, if your highest volume was 20, we could make each of our lines worth 2 if you wanted. All right. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, and so on. So that way that if our highest volume was 20, then we can fit it on our axes, but also our graph is going to be nice and big, and that's what we want. All right. Next thing what you're going to do is you're going to plot your data points. You're going to plot your masses, and you're going to plot your volumes. And you should have 4 data points on here. All right. So what I would suggest is to pause the video and then plot your data points. Okay. What I'm going to do is I'm going to sort of make up some numbers so we can learn about what the slope of the line will tell us. Okay, but for you, I would suggest plotting your data points, and then we'll go from there. All right, I want to put some random data points on my graph here. Okay, and let's say those are my data points that I have. All right. Now, what you would typically be asked to do, like in your math class, is to, if you have data points like this, and we think it's a linear relationship, what we would do is we would draw a line and then calculate the slope. So we would want to do a line of best fit, and what we can do is that we can try to fit our line in between all of our data points. Okay, it might hit a data point, it may not, but we'll just kind of have to estimate. So if I was doing this on paper, I would typically have like a ruler. I'm just going to try to eyeball it right here. Okay, so that would be my line. It's roughly straight, and we notice that my line doesn't hit all the data points. In fact, it barely hits one of them. And so when we are calculating the slope here, for instance, we know that the slope is the change in y over the change in x. Or we could think about it as the rise over the run. Okay? Now, when we do that, the key thing to remember is that you're going to be calculating the slope of the line, not the slope of a data point. So you would have to choose some points that hits on the line. Now, we could choose this data point here because it hits the line. But I could not choose to calculate the slope. I could not choose any of our other data points because these are not on the line. Okay? If you had a line where none of your data points hit, which happens pretty often actually, you can pick any other point on the line and just try to make it easy for yourself, like where does it hit and intersect in a value that you feel pretty confident that you could estimate. So like let's say that if we picked like this point here, so if I pick that point here, then my y value is 40, and I would have to maybe estimate how much this is, something like that. So if we thought that it was around, I don't know, 8.5, 8.7, something like that. Or we could choose, for instance, like this point here in the middle. I know the volume is 10, and then it might be easier to estimate this way, maybe a volume of, say, 40, or excuse me, a mass of 46. So, but it's just got to be somewhere on the line. Kind of a nice cheat code is that you can always use 0, 0. That's also a point on your line. Okay? Now, once you calculate you pick 2 points in the line and you calculate your slope, what does it really tell us? Well, we can think about, since all of these numbers that we have on our graph came from our lab, and so these points that we measured, the mass and the volume, those are measurements. And so if we look on the y-axis, what do we have? Mass. Well, if I'm looking at the change in y, I'm really looking at the change in the mass. And if I'm looking at the change in x down here at the bottom, all of these values, the x values, those are volumes. So we should recognize this formula, mass over volume. This is how you calculated density. So one of the things we're going to ask you to do is plot your data points, graph your data, and then we want you to calculate the slope. Why? The slope is actually going to tell you the density. Okay? Now, actually more accurately, because we're doing a line of best fit through here, this is actually the average density. So that line of best fit that we have, that's it's in between our values, and if we did a decent job of doing a line of best fit in between our data points, we would be coming up with the average density. So then the last bit that I'll just mention is that when you calculate your density, In science class, we want you to calculate that out, come up with a decimal. I know in math class they want you to do this as a fraction, but we're going to want a decimal because you calculated density from your mass and your volume values and you averaged your 4 trials. But we want you to calculate when you calculate your slope, do that as a decimal so you can compare them. And they should be very, very close to each other. All right? Thanks for watching.